Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Good evening, everyone. Can you hear me?
Good evening,
Yes,
Doctor.
doctor. Yes, doctor.
Good.
Yes, doctor.
Thank you. I think we can wait for another um another 2 minutes for that so that we can have our friend together in this class. Today is the 6th of January. Did you get the recording of previous lecture? It is in the Google Drive. Okay, one more. We have 18 plus 2, 20. Yeah, 19, one more. Let me check here. Okay, 19 minus 2, 17. 19, Ahmad. Ahmad no Shafiq is still not around. Shafiq, you are here already?
Yes, doctor. I'm here.
Okay, thank you. Alright. I think okay, Kausalya is here. Nadia is here. Aziza is here. Nurul Shafiqa. Okay, I think we can start our session today. Today I want to talk about discriminant analysis, and I hope that I can touch on PCA together with discriminant analysis. Okay. Are you okay, class? Can I start now? So, what is discriminant analysis? Are you ready over there? Are you ready? Okay. Just want to check whether you are ready or not. Wait, Our notes today is going to be taken from CH4_DA version 2. I think the latest file containing numbers of MATLAB codes and script is available today. So you can check the latest code. Yeah, delete the old one. You download the latest one from what I uploaded today. Yeah, under the CH4_DA_ version 2. Yeah, I add a few codes, few script. If you get the codes here, I think starting from today, 919191. Yeah. So later I will teach you how to use this code. Before that, I will describe or I will explain the theory behind discriminant analysis. What is discriminant analysis? Okay. Basically, discriminant analysis is a statistical technique to determine the group membership. In your area, if I can highlight example of palm oil, you have a class of palm oil and non-palm oil. Yeah, so that is what we call group membership. Or maybe you have a grade of palm oil, grade 1, grade 2, grade 3. Who is involving in palm oil? Pavitra, I think. What is class of palm oil that you have in your work? Can you please help me?
Class means how, doctor? Because we have with different iodine value, something like that.
Okay, that one is eigenvalue. Is
Yeah.
there any classification based on eigenvalue that you can make?
We have NBD first Olin,
Okay,
and then we have NBD super Olin.
okay. So from the eigenvalue, you can classify into two categories.
Yes, doctor.
Yeah. So from one data, you can divide into another class. Yeah. So what is the eigenvalue for each class? Can I have some idea from you?
Um,
Okay. What is eigenvalue?
Iodine value is the unsaturation calculation of the palm oil, doctor.
Okay, right. Unsaturation value, yeah.
Yep.
So what is the value ranging from
For IV 56, it will be ranging around 56 to 59.
56 to 59? Okay. What is the good value for eigenvalue?
For IV Olin around IV 56 will be 57.
56 to 57 is what?
Normally, for a good Olin, the IV will be 57.
Okay, 57 is the good one.
Yes.
How about above 57?
Above 57, the PPP value is higher, doctor.
Higher.
Yep.
So you consider that below 57 is good or what not?
Sorry, doctor. IV below 57, the PPP will be lower.
Lower,
Sorry,
okay.
yes, lower. Actually, more higher the IV is actually good because the saturation value is lesser. But according to the how to say cost or any output, we consider 57 is the best.
Okay. Which means that 57 above is the best. Can I say
Yes.
that?
Yep.
Okay. Now the borderline of the classification of palm oil based on iodine value is 57.
Yes.
Okay, I can say from the point of discriminant analysis. Later, I will show you because I have the data of iodine value as well. So iodine value higher than 57 is good one. Yeah. So we can give name good,
Mm-hmm.
good class. For below 57 is not good. Say I'm not going to use extreme word. Not good. Yeah. Not good. Yeah. Okay, so from the value of from the value of iodine value, we can classify palm oil into two categories: good and not good. That is what we call class membership or group membership. Understand?
Okay, doctor.
Okay. So if you look at number 4 here, okay, number 4. Normally, non-metric, categorical, and independent variables are metric or continuous. In other word, the classification that we want to make is being divided into categorical data: class 1, class 2, class 3, class 4. Okay. The data is coming from continuous data, which means that uh, 56, 57, yeah, okay. So in this work, in discriminant analysis, we are going to not to determine the eigenvalue, but we are going to classify the data into good and not good. Yeah. So a lot of parameters used to classify or divide the data into group or classes. Okay, there are a lot number of prediction can be made. For example, number 6, to predict the future sample. Say for example, you already developed the method from the IR. Okay, so here you have the sample of palm oil. So you have the ideal value of palm oil. So from the ideal value, you can classify into good or not good. So that in the future, if you already have the IR, you can use the IR to classify quickly which sample is good or not good. That is what we call discriminant analysis. Okay. So the variables that you have in my area is coming from IR, is coming from infrared or near IR and IR, or maybe coming from Raman spectrum. Okay. So how about you, Pavitra? Which data that you are using to get the spectrum from? You are using near infrared or Raman spectrum?
For IV, doctor.
Yeah, no, sorry, for the spectrum of the palm oil. Did you gather the spectrum for the palm oil?
Mm,
No, you don't.
we don't, doctor.
Oh, okay. So which means that you are just receiving the sample of palm oil, and you are just performing an experiment or testing the ideal value.
Ah, yes, doctor.
So from the ideal value, you can say that the ideal value for this batch is this amount, and the ideal value for this batch is this amount. Yes.
Yep.
Okay. Now, when you talk about chemometric, what chemometric can do is like this. You already have the sample and you already test the ideal value. And then from the ideal value, you can put the category or put the group into good and not good. Yeah. And then that sample, the same sample, you get the spectrum. Yeah, get the spectrum, or you can use IR or Raman or near infrared, get the spectrum. And then what chemometric can do is you try to find out whether from the spectrum can we classify the 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 category of palm oil, whether it is good or not good, which means that you are going to compare statistical technique with the actual data that you get from the experimental value. Understand?
Okay.
Okay. Now later I will teach you how the methods can be carried out. Yeah. Okay. This is what we call discriminant analysis, but there are a lot number of discriminant analysis. The basic of discriminant analysis is linear. Okay. Say, for example, if you look at my slide number 44, yeah, I try to make it bigger. Okay, I try to make it bigger. Okay, I have two variables. Yeah, I don't put the variables number here. Just simply want to make you just see what is going on here. We have two variables, x and y. Okay, let me try to put a color on it. Yeah, we have two axes. Yeah, this one is y, this one is x. Yeah, we have the data x and y, two variables. Yeah, this one is y, this one is x. Okay. We plot the graph and we label. So this is class one. We call it versicolor, and the blue one, we call it virginica. I will explain later what is the meaning of versicolor and virginica. Okay. The center for the red color is this green one, green square. Yeah, green square. And the center for the blue is a blue circle, a green circle here. Okay. Now, if you look at these 2 points, yeah, the center, you can draw the line. Okay, you can draw the line so that the line, okay, the next graph, yeah. This line is going to divide green and red and blue, red and blue class, versicolor and virginica. But if you look at the line, the black line here, okay, the black line here is the what we call class boundary, or the boundary that will separate red and blue. And the distance at any point of this black line, the distance between the point at any point, the distance between this line with this green and this green are the same. It is always the same. So because they are the same, we call it linear distance. Yeah, linear distance. So unfortunately, there are some of the point like here. Let me try to make it bigger. Yeah? Okay. So the red sample, these two red, is on the blue area. Yeah. And this blue sample is on the red area. So we call these three sample has been misclassified. You understand? Okay. This is what we call discriminant analysis, and the line that separate the two classes is called boundary, or normally we call it class boundary. Yeah, class boundary. So this is two class system where you can put one line here to separate. So this line is the same distance between the center to the center. Okay. Okay. Now, next slide. Okay. What we are going to do next is to see how we do discriminant analysis to classify data point. Okay. Now, I'm going to use data set. I will explain what is the meaning of data set that we are using. Okay. So basically in MS Excel, we are going to have a label of our data set, class label. In your case, in palm oil, we have two class of palm oil, and we have variables. For IR, we have the maybe the absorbance of the sample at each wavelength. But here in this case, we have four variables only: sepal length, sepal width, petal length, and petal width. I will explain later what is this. Yeah. Okay. So I'm going to use Fisher Iris dataset. Okay. Fisher Iris dataset. You can read the origin. This is the fundamental. If you want to understand discriminant analysis, you have to look at this data set. Okay, this data set has been published in Good Journal in 1936. Yeah, you can click this one to find that journal. Okay, what happened is that they have a sample of flower. Yeah, iris flower. Yeah, iris flower. Uh, they measure for each flower the distance of the sepal and petal. Yeah, sepal and petal. So this is what we call sepal length. This one is sepal width. This one is petal length, and this one is petal width. Yeah, petal width. That is why I put here sepal length, sepal width, petal length, petal width. Yeah. So they have three species of iris flower: Iris setosa, Iris virginica, and Iris versicolor. Okay, I have the data, the full data. You can download the data in MATLAB as well. Don't worry about this. Okay. If you want to know, if you want to see what is the picture of Iris setosa, Iris virginica, you can Google. Okay, easily you can you will find the sample of picture of these three species. Okay, now from these three species, as I mentioned just now, they are collecting a sample of each species, 50 sample. From those 50, they measure the sepal length, sepal width, petal length, petal length and petal width. Yeah. Okay. Now, this data is a good data because when you plot the graph of sepal length with sepal width, yeah, sepal length and sepal width, you will get this plot. Yeah, but when you plot petal length and petal width, you are going to get this plot. Yeah. So what is the meaning of this plot? So from this plot, you can see that the red one is setosa. Setosa can easily being discriminated, but Virginica and versicolor highly overlapping. Yeah, you can see here, and you can see, but certain variable can be used to classify versicolor and virginica. But setosa is quite distinctive from its class, from the use of the petal length and petal width. Okay, now, so how to classify this sample? Okay, how to classify this sample or this class? So there are lot number of classification method. There are lot number of idea how we can draw this line. Okay, the basic method that to draw this line is what we call equivalent distance or linear discriminant analysis. Okay, so we have EDA, we have LDA. I think if you Google chemometric and classification method, you can easily find LDA. Okay, and you can easily find partial least square discriminant analysis as well, PLSDA. However, there are lot number of classification method in chemometric, which is coming from machine learning community that we call quadratic discriminant analysis, supervised self-organizing maps, learning vector quantization, support vector machine. This is just only an example. In my MATLAB script later, I will have another sample or another type of classification method. Okay, so for each classification method, we actually will calculate the distance from each sample to the center point. Here, the distance from the center of each group. Let me try to show you this one. Yeah, for this one, okay, is how we calculate and we get this line. This one, okay. We use Euclidean distance. So that is why we managed to get this distance, so that this distance will classify whether each sample is belong to each class. Okay. However, there are some other method to calculate the distance. We have QDA, we have LDA. You don't have to worry about this, but as long as you understand the idea is the most important one, because this type of calculation can be made or can be calculated easily in MATLAB. You just put, you want to use QDA, you want to use LDA, they will create, they will they will calculate for you. Automatically, you can easily see which sample is belong to that particular group, and which sample is not belong to its group, like this. Yeah, you don't have to worry about this. You can ask MATLAB. You can write the code. I already provide the code for you actually. So you just simply put what type of classification that you want to do. Okay. Later, after we take a break, at 8 o'clock, I will show you how we do this. Okay. It's very, very easy. As long as you understand when to use it and why we come up with this line. Okay. Because this line is straightforward. Okay. Very easy to find, very easy to understand. Later, we will have another method. Maybe the line is not straightforward like this. Maybe we are going to have a curve. Maybe we can have a zigzag. They will find their way to classify the data. Okay, next. Okay, now as I mentioned just now, the basic discriminant analysis method is linear discriminant analysis. And quadratic discriminant analysis is a very simple as well. Very similar because the formula is not very far between these two, right? What is the meaning of Euclidean distance? From the formula, I put the breakdown here. Actually, I got this slide from Copilot. Okay, if you unable to understand, we are just calculating the distance between each group to the center of the group. Okay, this is how we write the formula in MATLAB. Okay, I can teach you later on how to calculate this in Excel. Okay, but I think if you go through this slide, you can understand that we are just calculating the distance from each sample to the group of its class. Okay, so now I explain again. The green one is number one here. Number one here is the center for the green square is the center for the red. Green circle is the center for the blue, right? The line here is the distance between the green square and the green circle.
Doctor, sorry, doctor.
Yeah.
Doctor, how we will get that green circle between the two variables, doctor? It will come out in the software?
Yes, yes, the software. I will explain which code, which part.
Okay, doctor.
Okay, I will explain in Excel and in MATLAB. This one is just plotting. What most important here is you have the red one, and you find the center for the red. So you put it here. You have the sample for the blue. You just find the center for the blue here, which means that the average, yeah, the average for the blue is here. And then you can draw the line. This line is always giving you the same distance between the square and the circle. The square of the green and the circle of the green. Yeah, square green and circle green. So circle green. Yeah. All right. This is what we call linear discriminant analysis, the basic one. Okay, because of this boundary, we can see now one of the blue is not belong to its group, and two of the red is not belong to its group. This is what we call misclassified data. Okay, is there any question that you like to ask? This is the most important one. I need you to have an ability to understand. This is what we call discriminant analysis. The root of chemometric when you talk about classification. Okay. Any question? If you don't have any question, put number one. You
Doc,
have, yeah,
sorry.
yeah, Asma.
Um, I just want to ask. You will explain later whether which discriminant analysis that we will use for what kind of data, right?
Yes.
Okay, doctor.
Okay. Any more question? No.
Doctor, I just want to confirm about my understanding. So
Yeah.
basically, how you want to get this boundary line, we will use the EDA, the three items just now, EDA, QDA, or LDA, right?
Yeah.
To get the line,
Yes. Yes. Yes.
which this can get from MATLAB or Excel, is it correct?
Yes. Yes. But
Okay.
MATLAB you have to write on your own. But in sorry, in Excel you have to write it on your own because we don't have that program. In MATLAB you can use. I have already the codes for that.
Okay, Doctor.
Okay.
Noted.
Okay. Later, when you change the code, you will see the line is slightly different. Okay, which means that they are going to give different idea on how to classify the data. Okay. Next, any more question? No. Okay, good. I will proceed with the next slide. We have Mahalanobis distance. So the way we calculate the distance between one point to another point is what we call Euclidean distance. Okay. So you see, you can compare the value, okay, or the formula. This is what we call Euclidean distance. But this one is what we call Mahalanobis distance. We put the C, what we call here is inverse of covariant matrix of group of each group. Okay, we have Mahalanobis distance. You don't have to worry about this. I will explain later when we try to put this formula into programming or codes. Okay. And we have linear distance as well. The formula is like this: CP. We have what is CP? With CP is given by this formula. Okay. Okay. Now, um, you have to you have to plot here. Plot. So, which one that you think you can easily separate? Plot A or plot B? Look at the plot. Which one is easy to separate? Plot B, yeah? Plot B. Because plot A here is quite number of the sample is overlapping. Yes, good, good. So you should expect that when you have highly overlapping sample like this, the percentage of misclassified is high. Okay. Okay. Now, this is two variable plot. Yeah, variable one and variable two, they're the same. But when we comes to finding the classification, maybe we can classify based on more than two variables. Okay. So we are not able to see clearly how 3 dimension, how 4 dimension can be classified. Okay, for two variables we can draw the line. Yeah, for three variables maybe we can draw the plane to separate the class. Yeah, later I will show you how we can do it.
Sorry, doctor. Can I
Yeah.
ask one question, doctor?
Yes, good.
Doctor, the two variables is overlapping because there is lot of similarities, is it, doctor?
Yes, true. Yes.
Okay.
Yeah. Yeah, good. Here in the advanced method in classification is that we can apply or we can implement variable selection. We can find out which variable is significant for class 1. We can find out which variable is significant for class 2. statistically significant. So if we manage to find out which variable is important, we just focus, if you want to do classification, on that particular variables only. Therefore, we can find the better classification method. Okay, look at these two plot. Yeah, look at these two plot. Actually, what I'm doing on my data set, this is true data set. I have a class 1 and I have class 2. Okay, now this is the plot when I use all information. Yeah, I make a summary of from all information into two variable, variable 1 and variable 2. Okay, so I use another statistical method to find which variable is significant for class 1 and class 2. So statistically significant, I subtract only certain variable and I plot another graph like this. So now I can see that variable 1 and variable 2 that I use in plot A high containing similar information, so that I'm not able to fairly separate these two classes. But when I change another variables, variable and variable 2 here, I can sort of finding a way to separate these two classes. Okay, next, which one? A or B?
A, don't have.
A. Okay, A. All right. Next, A or B? Slide number 57. B. Okay,
B.
B. Yeah. Actually, you can what? You can predict. Okay, you can choose from your very eyes. Yeah, you can compare A and B, isn't it? Which one is better? Which one is good, isn't it? Because you can see the A or the other plot is highly overlapping. Yeah, good. Okay. Now, is that possible to calculate by using our eyes? Is it possible if I ask you? If I ask you, is that possible to calculate? Okay. Can you answer that question? Possible to calculate? Yes, your answer is correct. B. Can you calculate how many is being classified? Is being misclassified? No. Yeah, you cannot. Yeah, good. So is that possible? It is not possible. That is why we need to use MATLAB. That is why you need to use programming software. That's why you need to use MATLAB. You have to use maybe Unscrambler, the software that I mentioned before. You have to use maybe SPSS. You have to use maybe R. Maybe you can use XL stat. To calculate the percentage error. Okay. Now, for iris dataset, actually the class boundary can be seen if we manage to put the boundary like this. Yeah. So the green one, the green one is how I can separate the green line. The green line here is how I can separate between blue and red. Yeah. So there are two methods to create the line to separate between green and between blue and red. So one is straight line, the other one is quadratic line like this. Yeah. So the quadratic line like this, the line like this is coming from this formula. This formula. Wait. Wait. Quadratic. Wait, I don't have that. I don't have that formula, I think. I don't put the formula for quadratic distribution analysis. It's okay. It's okay. But the method to calculate this line is different from LDA. Yeah. So the same, if I want to separate between red and black here, red and black, I can put a linear discriminant analysis, and I can put a quadratic. So quadratic will be like this. Okay. Without boundaries, you are not able to see how we can separate the data. Okay. Next. Okay, I have the same plot. Yeah. Okay. This one is just only LDA to separate between blue and red. This is the line. Magenta is the line to separate between red and black. Yeah. This is without boundaries. Yeah. This is the quadratic boundaries to separate between red and blue. This is a quadratic line to separate between black and red. Okay. The same. I will teach you how to do this by using this function, this MATLAB file later. Yeah. Right. Okay. Now, when we want to classify or evaluate, after we do classification, we have to evaluate how good it is. Okay, for example, if I can reverse my slide here, okay, look at here. Now we can see that there are two sample from the red has been misclassified, and there are one sample from the blue is being misclassified. Okay, so how we evaluate our performance, yeah, whether this line boundary from the LDA is good or not is by using numbers of measurement. One of the evaluation that you can perform is by using confusion matrix. I will explain later. And we have from the confusion matrix accuracy and error. We have precision, we have recall, we have F1 score, ROC curve, log loss, cross validation, and Matthews correlation coefficient. I am not going to burden you with all of this, but the basic, I want you to cover the basic. The basics is confusion matrix. From confusion, you can get accuracy, and error. Okay, you can get accuracy, confusion from confusion matrix. You can get accuracy and error. So, what is confusion matrix? What is accuracy and what is error? Look. Okay. Now, when you perform classification, you can gain or you can get the result from classification into, you can divide your result into four distinctive items. We have TP, we have TN. TP and TN. What is TP and TN? T stands for true. Yeah. Positive and negative. Okay, positive may be class 1, negative is class 2. So if it has been classified into true classes, we can put it into TP and TN. But if it is wrong, yeah, we call it false. Yeah. If class 1 has been classified into class 2, we call it a false positive. If class 2 has been classified into class 1, we call it false negative. Okay. Put another idea like this. Say, for example, you have two class A and B. If A has been classified into A, we call it true positive. Yeah. A has been classified into class A. If B has been classified into B class, we call it BB. Okay. But if A has been classified into B, we call it AB. It is false positive. Yeah, false positive. Or B has been classified into A, we call it false negative. Okay. From this value, we can calculate the accuracy. Accuracy is the number of AA plus the number of BB divided by the total number of sample involved. Okay. So the opposite of accuracy is error. Error is AB plus BA divided by total. Or error is 1 minus accuracy. Okay. We can put accuracy like this as well. TP plus TN plus FP plus FN. This is the total number of samples. Yeah. Okay. Sometimes we use this formula. Okay. The formula of precision is like this. True positive divided by true positive plus false positive. Recall is true positive divided by true positive plus false negative. Okay. So the other definition of F1 score ROC curve you can find on your own. Okay. But as I mentioned just now, I wanted you to understand what is confusion matrix, what is accuracy. Because later, after we take a break, I will use Excel and MATLAB to make sure you understand how to calculate these two, 1 and 2. Okay. Now, look at here. Look at here, confusion matrix. All right. I have 10 samples here, 10 samples. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, out of 10, I have 4 samples from class 1, class A. Yeah, I have 6 samples from class B or class 2. Okay. It is not necessarily true at all time. You have the same number of samples for class 1A, class 2, or class A and class B. That is why I try to show you something like this. Okay. Later in your assignment, I will give another case study. You have to find your own formula of how to calculate the accuracy and error. Okay, look at here. Okay. How many A predicted as A? Or how many AA? Okay, look at here, class. You can calculate on your own. We have A. Okay, we have AA, this one, AA, and AA. Yes? So therefore, our AA is 3. Okay? So how many A's has been predicted as B? So A predicted as B is 1 that I put in red. Okay? So done. The first part. The second part is BB. How many B has been predicted as B? So we have 1, we have 2, we have 3, we have 4. So we have 4 here, right? So how many B has been predicted into A? So we have 1 and 2. So that's why we put 2 here. Okay. So how many errors? Errors is AB add with BA. Yeah, AB is 1, BA is 2. So 1 plus 2 divide by 10. That is 3 divided by 10, you will get 0.3 error. 1 minus error is accuracy 0.7. This is a very simple one. Are you okay, class? Do you understand? If you understand, put number 1. Is it easy or not? If it is easy, put your icon here. Okay, put your icon like this. Yeah, easy. Okay. Okay, good. Good. Okay. How about the rest? Do you find any problem with this? Okay. Now, what happened when we do chemometrics? Don't expect we have small sample like this. Maybe we have 1,000 sample. Maybe we have 3,000. Maybe we have 4,000 number of sample. Yeah. Maybe we have 122. So there's no point for you to calculate manually like this. We have to write our own program to find out what is AA, what is AB, what is BA, and what is BB. We can calculate our own codes or how to find the error. So we just can create a program, a code to put the actual value and put the predicted value. It doesn't matter how long it is. It doesn't matter how many of sample from A and B. They can, or the program can calculate for you automatically the error and the accuracy. Okay. You have any idea? You have any idea to do your own work like this at your workplace? Okay, to evaluate the performance of classification. Okay, good. Okay, now this is just only a sample of LDA iris dataset. We have codes for this, right? We have a sample. Okay, I try to make it bigger. Try to make it bigger so that you can easily see what is going on. Okay, I put the SIPA length and SIPA length for versicolor and virginica. And from the LDA, I can put the boundary for this. Okay, the program can calculate for you. The program can create the class boundary for you. Okay, at the end of the day, versicolor, which is the red one, yeah, is correctly classified 38. The blue one, Virginica, correctly classified to 37. Yeah. So the misclassified is 12 and 13. Okay. The program can calculate for you like this. Don't worry. Okay. So look at this situation class. We have the red and blue. Setosa is red. The blue one is Virginica. And as you can see, there is only one of Virginica has been misclassified. All of the Setosa is being correctly classified. So therefore, 50, 0 and 49, 1. Okay. Look at here. Only one from Setosa has been wrongly classified. So that we can see that there are 14, 41, 49, 1 and 0, 50. Okay, look. What I wanted from you to see is like this. Okay, like this. Okay. If you see that when I compare Setosa and Virginica, I use sepal width and sepal length as a variable. The result is 50, 0, 1, 49. Okay, but when I compare Setosa with versicolor, okay, the class boundary are not the same. Okay, therefore you can see different result. Okay, so comparing between one class to another class is going to give you different error or different accuracy based on class boundary and variables. Okay, are you okay with this class? You can calculate the error and accuracy from the result. I hope you can do it. Yeah? That's relatively easy for this one. I will teach you how to use MATLAB to get the plot and to get the result like this. Okay. So I have another idea. We have another idea actually to find the class boundary. Yeah, the class boundary. Here is the class boundary QDA. So for two classes here, we have versicolor and we have virginica. So the class boundary for QDA is like this, the curve. From this curve, they give you the output of the uh, uh, table, yeah, coefficient table like this. Okay, which means that Virginica 37 misclassified 13, versicolor 34 misclassified as 16. Okay, but for versicolor and virginica, okay, uh, here is sepal width, the one is sepal length, but different variables, petal length and sepal length. Yeah, I changed from sepal width to sepal length, different variables. Yeah, even they are coming from the same sample, versicolor and virginica. Can you see that the class boundary is not the same as this one? Yeah, so therefore the result is not the same. Okay, so what I wanted from you to understand from this 1 hour is there are a lot number of options that we can classify these two classes. Yeah, um, maybe we can change the variables. Maybe we can change the classifier or classification method. Okay, so that the result they are not the same. Okay, so in order for us in the future, in order for you, if you want to perform classification, you have to think what variable that you wanted to use to classify these two classes, number one, and number two, what classification method can be used to classify. So the performance of the classification can be generated, can be seen by looking at the confusion metric or confusion table like this. Okay, that will conclude our first lecture today, first hour lecture for today. Later, after the break, I will show you how to handle this, how to calculate this in MATLAB. All right. Is there any question?
Sorry, doctor.
Yes.
Doctor, the last part I'm not quite getting it. Just now, doctor said for to know the line that we want to draw.
Yeah.
Mm-hmm.
Mm-hmm.
I'm sorry, doctor. I didn't really get that point of the line, doctor.
The line is how we can classify these two classes. The
Okay.
line is based on classification method
Mm-hmm.
that we will choose whether we want to use QDA or whether you want to use LDA.
Okay.
Okay. So you don't have to worry. The idea is like this. The class boundary is the line. The line is based on the theory on how you want to differentiate these two classes.
Mm-hmm.
Okay. So maybe you want to use LDA, maybe you want to use LDA. So because they have different method to calculate the distance, that is why they have different class boundary, different type or different boundary from the formula. Okay, because they have different class boundary, that is why they give you different performance. Okay, so as a conclusion, in order for you to classify the sample, you have to look into what variable that you want to use, number one. And number two, what classification method that you want to use. Different variable will give you different area, different class boundary. Different classification method will give you different class boundary as well.
Mm.
Okay, actually we have another variables or another factor to 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 make sure that we have good classification method. But in this case, I just wanted you to understand that at least today you understand that different classification method, LDA in this case or QDA, will give you different class boundary, and different variable will give you different class boundary as well. Look at here, we have sepal width, sepal length, and petal petal length, and sepal length, isn't it? So different variable. I only change here sepal width. Sorry, I just change sepal width with sepal length here. So the plot is not the same. Okay, I hope I make you clear, huh? What you want, what you should know. Uh,
Doctor, sorry,
yeah,
doctor, another question.
yeah, yeah, good, good.
Doctor, how we will know which classification method we should use? Based on what, doctor?
Okay, based on the error.
Oh,
If you find this method will give you less error, which means that that classification method is better.
oh,
Okay, so definitely in this case, which one is good? This one or this one? Okay, on your left or on your right? Which one is better? On your right. Good, good. On your right. Okay, because the error is only 6, isn't it? Good. Yeah, good. Helmi, you are responding to my question. Okay. All right. Good. Yeah. All right. So I think it is 7 o'clock already. I hope that you enjoy this lecture, this sharing. I will introduce you how to use MATLAB after the break. Hopefully, you can have your own MATLAB in front of you so that we can run together. We can compare our plot and you can answer those questions. Okay. All right. Thank you. See you again, everyone, at 8 o'clock. Bye bye.
thank you, doctor.
Okay. Have a break. Yeah.